All right, we're going to continue our work on being able to use math and finance formulas for something that we might use later on in life. The first question we have, question number 14, is we're going to buy a house. So whether you buy a house or buy a car, we are going to basically deal with the same situation. So let's start. On December 31st, 2012, a $740,000 house is purchased with the buyer taking a 30-year mortgage at 4 3/8% interest compounded monthly. Well, we have 4 3/8%, and we want to take that mixed number and change it to a decimal. So we start with 4 plus 3 divided by 8, and we're going to write that as a decimal number, so it's 4 375 thousandths. I want to take this number and change it to a percent, so all I'm going to do is copy that amount. It always equals, it copies it easily with the percent sign. And you notice it says exactly the same thing, so it's 4 375 thousandths percent. The time is 30, the M is 12, and now we can go to part A. If a 10% down payment is required, how much is the down payment? Well, the down payment is going to be equal to 10% of the purchase price. So of always means multiplication. We're taking the 10% times the $740,000, which means that the amount of the down payment will be $74,000. Part B says, how much did they borrow? Well, the amount that they borrowed is called the present value, and therefore that is going to be the purchase price or the cost of $740,000 minus the amount of the down payment, and that means that they had to borrow $666,000. Part C says we want to calculate the amount of the monthly payment. So again, we go to our formulas, we go to financial, and we go to our payment function, and the interest rate is 4 375 thousandths divided by the 12, so that gives us our periodic interest amount. Now the NPER is the M, which is 12 times the 30, which tells us we have 360 payments. And the present value is the amount of the loan, which is $666,000. And therefore, we get the payment formula result on the template of $3,325.24. Well, let's go on and think about something else. How much of the first payment goes to interest and how much goes to principal? Well, we're going to use the simple interest formula for the first payment, but we're going to use the I, which is the interest rate divided by M, for the amount of interest that we have to pay on the loan just for the first payment. So we're going to use the formula of the interest amount is I is equal to the principal, that's the amount that we borrowed, times the interest rate for the first month. So therefore, our interest is going to be equal to the amount we borrow, which is $660,000, times the interest rate, which is 4.375%, divided by 12. And that tells us that $2,428.13 is the amount we paid for interest. Now we want to know how much we paid in principal. So we take the amount of the payment minus the amount of interest, and therefore $897.11 of our first payment goes to pay down the principal. And you will notice that when we go to an amortization table, that the amount that we pay in the principal is always going to be very small compared to the amount we pay in interest for our loans. All right, let's go to question number 15. Dan borrows $750 at 9% per year simple interest for 1 year and 2 months. Again, since we have 1 year and 2 months, we want to write this as a decimal number. So we have 1 year, which is 1, plus the 2 months. And since there are 12 months in a year, we're going to take 2 divided by 12. And that will tell us exactly how much we have to go ahead and put in order to get the time. Now, part A says, what is the interest charged? Well, how much interest is due on the loan? Therefore, the amount of interest due on the loan will be the I is equal to the principal, which is the P, times the interest rate, times the time, and that tells us that the amount of interest will be $78.75. How much is due on the loan? Well, that's going to equal to the $750 plus the $78.75, which tells us that total amount at the end of the 1 year and 2 months that Dan has to pay back $828.75. Okay, question number 16 is a two-part question, so let's read it and see what we have to do. Bill borrowed $1,000 at 5% interest compounded annually. He is able to establish a sinking fund to pay off the debt and interest in 7 years. The sinking fund will earn 8% compounded quarterly. What is the size of the quarterly payments into the fund? Well, let's go through this again. Firstly, Bill borrowed $1,000. He's going to make one payment at the end of 7 years. The interest rate is 5%. The time is 7 years because it's simple interest. Remember, it is just one because it's compounded. It's not simple interest. It's compounded annually. That means he's going to make one payment per year. So therefore, the amount that he is going to owe at the end of the 7 years is going to be equal to the principal times, open parentheses, 1 plus the interest rate divided by 1, just to keep everything uniform. And we have the N is the same as the T because 7 times 1 is 7. And that tells us he's going to owe $1,407.10. Now, basically, this $1,407.10 is the future value. So I clicked equals and I just copied the formula. He wants to set up a sinking fund. In other words, in the future, he wants the $1,407.10 to be there. He is going to make quarterly payments. The interest rate is 8% compounded quarterly. And he wants to be able to do it at 4 payments per year. All right, because remember, the time is 7 years. We're going to go to our payment formula because he's going to pay it back in 7 years. So again, we go to our formulas. We're going to go to payment. And again, the interest rate now is 5%. This time, let's go back there. The interest rate is no longer 5%. The interest rate is 8% divided by 4. The N per is going to be equal to the 4 times the 7. So he's going to make 28 payments. Let's try that again. They don't like that. So again, let's go back. Let's try it. The N per is going to be the 4 times the 7. That's the 28 payments. And the future value, because that's what we want, again, negative, is the $1,407. And notice the decimal number goes on because it was really more than that. It was rounded to the nearest penny. And that tells us that he has to make a payment of $37.98 each quarter. And then at the end of the 7 years, he will be able to pay back the loan in one lump sum. All right, now you go and practice some problems that uses these particular formulas.